Good morning. Good morning. Where are you? Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. Once again, a welcome all the class 9th students of various branches for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 9. Our ongoing chapter, which could be the chapter number 4, work, energy and power. And we are at the session number 3. So far, we completed 2 classes in understanding the importance of work, energy and power in our day-to-day life, in a regular life as well as in the life of physics. So we'll continue where we left in the last class. But before that, let us recall what we learned in the last 2 sessions. So in the first session, we discussed about the work. In second session, we discussed about the power. Right? So what is work? Or when you say work is done, that is we discuss. That is, if body moves along the direction of force, the work is said to be done. That means work is said to be done only when body moves. If body is not moving, even though you are applying any force, there is no work is done. The force should be applied, body should move. Then only work is said to be done. Whether the body is moving in the direction of force or opposite direction of force, that is makes the work as positive work or negative work. And there is some zero work also there. It is possible when the force and displacement are in the perpendicular direction or normal to each other. 90 degrees. I don't already right way fully. So this is about the work. Work, types of works. There are 3 possible types of works are there. One is positive work, when displacement of the body is along the direction of force. When displacement of the body is other than direction of force, negative work. Zero work is possible in 3 cases. One is when force is 0, when displacement is 0. Third one is when force and displacements at the angle of 90 degrees. All the 3 cases, you can find that the work done is 0. Right? So that is our work, what we learn. But in last class, we learned about the power. So power, when time comes into play, right? Time comes into play. Power will come. It's nothing but work only. But how fast you are doing work, the rate of doing work, or work done in a given time. In a given span of time, how much work you done, or how much work you done is faster. So everybody can do that work, but who done the fast? I already given so many examples. That is the power which is measured in either joule per second or watt, named after the great scientist. And even this power, higher units also there. So many other units like kilowatt hour, which is in our electrical consumption or electrical meter. I told you, go and see the electrical meter, right? So this is about the power we completed in the last class. Now today, our last part of the chapter is about the third word, that is energy. So we'll discuss about the energy today. So this is also nothing but work only. The capacity to do the work, the ability to do the work, how much capacity you have to do work. Here there is no time comes, no time. But your capacity, different people have different capacity of doing work. That capacity, or you can say ability, or you can say tendency to do a work. How much capacity you have, or how much ability you have, or how much tendency you have to do the work. Either it may be eating, or it may be running, or it may be fighting, or it may be talking, or it may be sitting for comfort for a long time. Anything. Different areas you can find the capacities of different people. Such capacity is called energy. See, all three are interlinked only. Without work, there is no power. Without work, there is no energy. All these are interrelated terms. So, such capacity to do a work is called energy. So, energy is also a work only. So, it is also measured in either joule or erg. Joule or erg, right? Joule in SI system, erg in CGS. Some practically, if it comes, we can have so many units, kilowatt or calorie, right? See here, 1 joule is equal to 10 power 7 erg. SI versus CGS. 1 electron volt is equal to this many joules. 1 kilowatt hour is equal to this many joules. I already derived. 1 calorie is equal to 4.818 joule. So all these are the units of energy, and which can be convertible. One unit can be converted into another. Okay? Then, what are the various forms of energies? Means, where is energy available? In which form this energy is available? So, mechanical energy, that may be either kinetic or potential. Mechanical means applied. Whether body is moving body also produce energy. A body at rest also can produce energy. These two are called mechanical energies. Chemical energy, electrical energy, all. Electromagnetic energy, some electric bells and all works, motor. Nuclear energy is a very powerful form of energy. Powerful form. Like bombs, atom bomb, time bombs we prepare. Na? Light and sound energy, light energy, thermal energy. Thermal is nothing but heat. Heat energy. So these all are the various forms of energies. Various forms, various types, where the energy is available, or we can use the energy of these forms everywhere in our daily life. Without these energies, we cannot spend a day. Starting from the day beginning to day end, we'll use the many of these energies. Except nuclear energy is restricted for a higher level. Remaining all mechanical energies, without that we cannot do anything. So if you want to lift your school bag, you want to move with your cycle, everywhere we need our muscular energy or mechanical energy. Chemical energy, some generally will use in the laboratories. Electrical, everywhere. Morning you switch off the fan, night AC. Electromagnetic, one kind of principle. Electric bell, or water heater, water motor. All these are works on this only. Nuclear, I told, all nuclear power stations. Sound energy, TV, when you want TV sound reducing, increasing, when sound comes to increase the sound, and maybe home theaters, so many things are there to produce. Light energy, same. Thermal heat energy, morning when you have to heat the water or heat the milk, everywhere it is the thermal energy too. Right? So these are the various forms of energies available in our for us. So we start one by one. We'll discuss little about one by one. You can see here the first mechanical energy. Mechanical energy can be either kinetic energy or potential energy. Right? So kinetic energy is nothing but energy possessed by a body, virtue of its motion. Every moving body produces energy called kinetic energy. Every moving body, either it is cycle or car or aeroplane or boat, all these energy produced by them is called kinetic energy. Okay. So flowing water was kinetic energy. Moving vehicle was kinetic energy. The moving hammer was the kinetic energy which is used to drive the nail into the wood or wall. A bullet fired from the gun possesses kinetic energy. All these are the examples for the kinetic energy, which is energy passed by a body in moving body or motion. So there is a formula is also there for kinetic energy, that is half mv square. This kinetic energy depends on mass and velocity, which is obtained from this. Derivation is not required for us, but expression for kinetic energy is half mv square, which is simply obtained from our equations of motion. From that we got a value and we applied in the W is equal to F into S. Where force is ma, we know, second law of Newton. A is equal to v square by 2s, which is from v square minus u square is equal to as. So the body is starting from rest. So u is 0, we consider. We apply some force here. Then what is the work done in moving from here to here? So first we calculate what is the distance covered. Then we substitute in the F into S formula. The work done is nothing but kinetic energy only. Force is ma, S is v square by 2a. We got half mv square. The W is nothing but kinetic energy. Kinetic energy is equal to half mv square. The unit for that is mathematical equation for kinetic energy. Right? So kinetic energy is nothing but energy possessed by a body, virtue of its motion. Whereas potential energy is nothing but, for example, second case, potential energy, I don't know why not explained. When you come to the second kind of energy, I'll show here. Potential energy is given by mgh. Energy possible by a body, virtue of its position. For example, here we have one big stone on earth. Right? We want to lift this up to certain height. We want to lift it. So, up to certain height. So, what is the work done here? Work done is called F into S. So, what is F? F is nothing but weight. That is mg. S is nothing but height. That is mgh. So, potential energy is given by the formula mgh. The amount of heat required, the amount of energy required to lift the body. It is in same position only. Same position it is producing energy. But to move the body to a height of h. So that is given by mgh formula. Right? That is totally about what are the mechanical energy. Either it may be kinetic energy or it may be potential energy. What is the energy applied by us? Muscular force. When you are lifting the dumbbells, that is a potential energy only because you are not moving there. Same position we are lifting and getting the exercises. So the energy possessed by a body, virtue of its motion is called kinetic energy, which is given by kinetic energy is called half mv square. Second one is the amount of energy possible by a body, virtue of its position. Like overhead tank, water is there. The water is remains at the same height, but they are coming and flowing, coming to the tap. That energy possible by overhead tank is nothing but potential energy. It is given by mgh. Right? Now, very important, work energy theorem, which shows the relationship between work and energy. Work energy relation is given by this. That is, the net work done by external force acting on a body is equal to change in kinetic energy. Change in kinetic energy. So the work done is equal to change in kinetic energy as per. So work is equal to half mv1 square minus half mv2 square. We can say. So, or you can say u. You are no issue. So v1 is the initial velocity, final velocity. V2 is the initial velocity. Then what is change in kinetic energy? Half m1 v1 is equal to half minus this. Final kinetic energy minus kinetic, initial kinetic energy will give the work done. So work done on a system is equal to change in kinetic energy is the statement for work energy theorem. Right? So many examples also given for this work energy theorem. So in the case of vertical motion of a body undergoes gravity when the body is projected up, thrown up. The force of gravity opposes the motion and kinetic energy of the body decreases and falls down. When you are suppose on earth, you are throwing body upward direction. What happens as it's going upwards, its energy decreases and finally it comes down, fall in the earth. Correct? That is example is, at that case, some cases kinetic energy may increase, some cases can decreases. Where kinetic energy decreases, there is a potential energy increases. But total energy is always constant. Potential plus kinetic is equal to mechanical energy, which is always constant, whether the body is dropped or projected or moving along the road everywhere. Because we know that energy neither be created nor destroyed, as per law of conservation of energy, which we learned in the earlier classes. So already I told about potential energy. Examples, so many are there, can be defined for the conservation of forces. So potential energy on the frame of reference. So that is given by mathematical formula mgh. Potential energy is given by mgh. Mass into acceleration due to gravity into height. So these are gravitational energy, electrical energy. There is no need. All these are the same. So next law of conservation, we have to verify. We are saying that the total energy in a system remains constant. That we'll discuss after seeing this video on energies. Then we'll move to the last part of the chapter.
Earthpen. Hello learners, this is Earthpen. Today, we are going to talk about another fun topic in physics. It is all about the types of energy. Energy can be categorized into two broad topics, the kinetic energy and the potential energy. These two are the basic forms of energy, and we know that kinetic energy is the energy of moving objects, while potential energy is energy that is stored. But aside from these two energies, there are also other types of energy. This includes thermal energy, radiant energy, light energy, chemical energy, nuclear energy, electrical energy, gravitational energy, and mechanical energy. Let us discuss them one by one. The first type of energy that we're going to discuss is the thermal energy. Thermal energy, or also called as heat energy, is produced when there is a rise in temperature that causes atoms and molecules to move faster and collide with each other. But how is thermal energy produced? Thermal energy is the energy that comes from the heated up substance, which means that the hotter the substance, the more its particles move, and the higher its thermal energy. To better understand this, let us have an example. Say you have a hot pot. You forgot that the pot is hot, so you grab it with your hand. Now your hand is burnt because of the hot pot. The thermal energy from the hot pot is being transferred to your hand. That is why you felt the burn in your hands. So, better be careful when dealing with hot things. The next type of energy that we're going to discuss is the radiant energy. So what is radiant energy? Radiant energy is a form of electromagnetic energy. This type of energy can take form of visible waves, which is what we call light energy. But we will be talking about light energy later. The sun produces a lot of radiant energy, which is transmitted to Earth as light. Radiant energy that is transmitted by the electromagnetic waves can come in different forms. Some examples of radiant energy are from the sunshine, X-rays, and radiant heating systems. I have mentioned light energy and radiant energy. But what is light energy?
अपनी सुपर पावर यूज करने का टाइम आ गया।
आप टेंशन मत लीजिए, IIFL फाइनेंस से झटपट गोल्ड लोन लीजिए और बिजनेस आगे बढ़ाइए।
लाइफ जब भी आगे बढ़ने का मौका दे, अपनी सुपर पावर, अपना गोल्ड यूज करिए और IIFL फाइनेंस से गोल्ड लोन लीजिए।
IIFL फाइनेंस करता है सीधी बात।
Light energy is a form of electromagnetic radiation of a wavelength, which can be seen by the human eye. It is a type of kinetic energy. In an electromagnetic spectrum, we can see that light has the wavelength visible to our eyes. Light energy is formed through the movement of photons. Photons are like tiny pockets of energy. So when an object's atoms heat up, photons are produced from the movement of atoms. Also note that the hotter the object, the more photons are produced, and that is how light energy is formed. If you're asking how light energy is used, well, basically, light energy is used to help us see. The light can either come naturally with the use of the sun or fire, but it can also be from man-made objects like candles or light bulbs. Light energy is also used by plants during photosynthesis. Plants capture the light energy from the sun and use it to produce their food. Next, we have the chemical energy. Chemical energy is stored in the bonds that connect atoms with other atoms and molecules with other molecules. Because chemical energy is stored, it is a form of potential energy. So what does that mean? It means that when a chemical reaction takes place, the stored chemical energy is released. Chemical energy is the most widely used type of energy in the world. Most humans don't know that they are already using chemical energy. But how is it used? Chemical energy can be found in your food, in a burning wood, and even in photosynthesis. Chemical energy is produced in the food that we eat, and that energy keeps us warm, helps us move, and allows us to grow. Stored chemical energy can also be found in coal, biomass, and chemical batteries. Next type of energy is the nuclear energy. Nuclear energy comes from the nucleus of atoms. How is nuclear energy released? It is released by nuclear fusion or nuclear fission. Nuclear fusion is when the nuclei are fused together, while nuclear fission is when the nuclei are split apart.
Atom bombs.
Nuclear energy is a non-renewable energy source that comes from the nucleus of atoms. Nuclear plants use nuclear fission of a radioactive element called uranium to generate electricity. So how does it work? The nucleus of our uranium atom is hit by a neutron. It causes the uranium atom to split into two atoms, and at the same time, the energy is released in the form of heat and radiation. And as a result, more neutrons are released, which means that the process repeats itself. Or in simpler terms, there is a chain reaction during the process. Did you know that nuclear power plants must shut down every 18 to 24 months in order to dispose the used uranium fuel? This is because the uranium fuel becomes a radioactive waste. Moving on to the next type of energy, we have the electrical energy. Electrical energy is caused by the movement of electrical charges called electrons. The faster the charges move, the more electrical energy they carry. Since the charges that cause the energy are moving, then we can say that electrical energy is a form of kinetic energy. So what are the examples of electrical energy? The first example that we will tackle is during a thunderstorm. when there is a thunderstorm, we can see lightning, right? Did you know that lightning is a form of electrical energy? That's right. Lightning is a form of electrical energy since during a thunderstorm, two electrically charged regions in the atmosphere temporarily equalizes themselves, causing the instantaneous release of energy. In other words, electricity in the atmosphere is being discharged. Another example, we place.
So anyway, we'll continue the same in the next class. So there are various forms of energies you can see there, how they are working. Now this is the last part, law of conservation of energy. Simple one, the total energy in a system remains constant. Energy can neither be created nor destroyed. We cannot create energy, we cannot destroy. But what happens? It converts from one form to another form. For example, when you are running a vehicle, we will fill the 1 liter petrol. After 40 kilometers, you will stop. Petrol is over. Is the petrol is wasted? No. The petrol is the heat energy. It converts into mechanical and makes the vehicle to move. It doesn't mean that we are wasted. We are using electricity at home. So many, by end of the month, we get the bill. It doesn't mean that electricity is wasted. We are using electricity to convert into either heat energy or cold energy or mechanical energy. They are converting. There is no waste. Similarly, when a body is coming down, that is called freely falling body or projected body also, both bodies will have the mechanical energies. Either it may be kinetic energy or potential energy. What happens while they are coming down? The potential energy at a high point, because of more height, the potential energy is more. But when body coming down, as height decreases, the potential energy decreases, but kinetic energy increases. Like that, whether you have projected the body also same. At every point, the total energy remains constant. Potential energy plus kinetic energy is always constant. Sometimes potential energy is more, sometimes kinetic energy is more. But overall, both are same. That only explained here. Different point you consider for a freely falling body. When a body is dropped freely, so mechanical road energy is equal to kinetic and which is constant. Why? Because we know that energy neither be created nor destroyed. One example is taken in case of freely falling body. When you are dropping a body from here, at highest point, the total energy is nothing but mgh, because h is highest point, it is height. So kinetic energy, there won't be any kinetic energy because u is 0. When you are holding the pen like this, what is the velocity of the pen? 0. When velocity is 0, kinetic energy is 0. But which is at the height of h, so potential energy is maximum. So the total energy at a point A is mgh. Right? Plus 0 is 0 only. Kinetic energy is 0, potential energy mgh. But when you come to point B, we came middle here. Point B. Point B, what happened? The total highest potential changed slightly. So potential energy is one thing and kinetic is different. Potential energy decreases, kinetic energy increases, but total energy is again mgh only. Right? See here. So here see, here what you got, second case, point B, the potential energy is given by mgx, the kinetic energy. Potential energy is nothing but mgh minus x, because it's already covered some distance. So total energy again mgx only. Same way. Even though there is change in kinetic and first case, kinetic energy is 0, potential energy is mgh, total mgh. Second case, kinetic energy is mgx, because the distance traveled is considered as x. And potential energy is mgh minus x. So substitute to get the total energy is mgx only. When you come to C, little down, so here also you can get the total energies. See, kinetic energy becomes mgh. But potential energy become, when you see the potential energy becomes 0 here. When body touches the ground, as height is 0, potential is 0. So what is the total energy? 0 plus mgh. That is mgh only. In all three cases, the total energy constant. The first case, potential energy is maximum, kinetic energy is 0. Second case, both are having some value. Third case, potential is 0 and kinetic energy is mgh. So overall, the total energy in a system remains constant. That is called law of conservation of energy. So for that example, so many examples you can give. Even pendulum example also they give when you go to the next class. At this point, and at middle, what is the total energy? Kinetic, potential, kinetic, potential. Right? So very cases can prove this. This is applicable everywhere, every energy. The total energy remains constant, right? Because the energy neither be created nor destroyed. The total energy in a system is given by potential energy plus kinetic energy. Whether it is a freely falling body or vertically projected body, that is not given, only one case is given for you. Okay. So with this, I think we have done with the chapter work, power, energy. So this is all you have to work on. So work on this level 1, level 2 and level 3 if anything is there, the questions. And if you have any clarity, you can ask your teacher to provide the key already provided for them. You answer them. Whenever once you complete the syllabus, I'll start explaining the worksheets also in the coming days, right? So till then, next we'll start new chapter. Till then, you try to complete this in our notebooks or in the material readily, right? So that's all for today, students. So you have completed what is work, what is power, and what is energy. All the three. Thank you, everyone. Have a wonderful day. Thank you. Right? Thank you, students. Have a wonderful day.